Right, now that we've done this introduction to this idea of the fact that there's four angles in the Cartesian plane that all have the same ratio. Two of them are positive versions and two of them are negative versions, but ultimately they're all related to the same numbers. So now that we did that in topic 3.1, we're going to start looking at three specific reductions. We will do a fourth one, but these first three are all kind of the same family. So our first one, which is 3.2, is the reduction with 180 degrees minus theta. So now we're going to look at the general concept. So if you have an angle of theta made in the Cartesian plane, r represents the length of the line from the origin to the end, which is I've called p. I've labeled the x value as a and the y value as b. So we can work out the sine and the cos and the tan ratios of theta using a, b, and r. So what is sine of theta? Sine of theta would be y, which is b, over r. Cos would be x, which is a, over r. And tan would be y, which is b, over x, which is a. So those are all the trig ratios related to theta in terms of a, b, and r. Now we want to create an angle of 180 degrees minus theta in this Cartesian plane. So how is that done? We saw this in the first video. If I reflect this line over the y-axis, that will be an angle of theta. So what angle does this create in the Cartesian plane? Remember, we always measure angles anti-clockwise from the x-axis to the line. So this will be 180 degrees, but take away theta. So minus theta. Now what point does that land me up at? I'm going to call this point P dashed, and it'll arrive at the point. You'll notice that the y value remains constant because you haven't changed the vertical level, so that's still b. But this reflection of the y-axis means that the a value becomes negative a, so that's the x coordinate. The r value would remain the same because r just represents the distance from the origin, so that doesn't change. So now what we want to do is we want to look at what is the sine ratio of this new angle, the cos ratio and the tan ratio, and how does this relate to theta's ratios. So sine of 180 degrees minus theta would be the y value, which is b, so that's b over r. Cos would be the x value, which is now negative a over r, and tan would be y over x, which I could just say is negative b over a. So now we want to see what relationships exist. Now we did kind of start this discussion in the first video, so these relationships shouldn't surprise us. So the first relationship I see is that sine of theta is b over r, and if you have an angle which is actually 180 minus theta, sine of that angle is still b over r, because all that happened is I reflected and my y value did not change. So my conclusion can be that sine of 180 degrees minus an angle can always be reduced to sine of that angle. Those are equal. It's equal to the positive version. Now that should make sense to me because I'm working in quadrant 2 and the sine ratios are positive in quadrant 2. So that makes complete sense. So let me just write myself a note here. This is positive because I'm working in quadrant 2. And sine of an angle in quadrant 2 is positive. So let's look at the next relationship. Cos of theta is a over r. If you rewrite an angle as 180 minus theta, it's still a over r, except it's now the negative version. So these are cousins in that they have exactly the same ratio, but this is the negative cousin. So therefore, I now can conclude that cos of 180 degrees minus an angle can be reduced to the fact that it is the same ratio as just cos of theta. However, it's the negative version of cos theta. So this is the negative cousin. So this is now negative, but for exactly the same reason. So because cos is negative in quadrant 2. So the reason why sine was positive is that we were working in quadrant 2, and the reason why cos is negative is because we're working in quadrant 2. So only sine's ratios are positive in quadrant 2. Now my last relationship is that tan of theta is b over a, And 180 minus theta has a tan ratio of b over a, but again the negative cousin. So exactly the same conclusion as cos. If you're trying to find the tan of 180 minus theta, it actually has the same value as tan of theta because of the symmetry, but it's the negative cousin for exactly the same reason. So cos and tan are negative in quadrant 2. So it might look like you have to remember these three rules, but what you'll notice is after the three kind of reduction videos, we're going to summarize, and then you'll realize that they're actually a really logical pattern and you don't have to remember too much. Now, the only way to make this a little bit more tangible and make more sense to us is to do some examples. So let's look at our first example. Can we, without a calculator, now without a calculator means chances are we're going to have to reduce this down to special angles. Now, I'm not spelling special right, so let me try again. We need to reduce everything down to a special angle, because special angles are angles that we should know the trig ratios of without a calculator. So my question is, can I rewrite 120 degrees? Now, you can rewrite 120 degrees as lots of things. 70 plus 50, 110 plus 10, I don't know, 130 minus 10. There's lots of ways to rewrite 120 degrees. But the only way that has relationships for us, because of the symmetry, is as 180 degrees minus the number. This, we know that there's a symmetry between 180 degrees minus theta and theta. So we can't rewrite it as anything. We must work with 180 minus theta. Now let's just draw ourselves a picture so we know where this 120 is. So if I drew a picture, 120 degrees is in the second quadrant, it would be about there. And so 180 minus that angle would give you 120. So that must be 60. So I'm going to rewrite 120 as 180 degrees minus 60 degrees. Now notice there's an equal sign there. So all I'm doing here is I'm rewriting 120. This can't have magically changed. So always ask yourself, is 120 equal to 180 minus 60? And yes, it is. Now what I'm doing is I'm doing the thing we call reduction. Reduction is changing this and reducing it to an easier ratio. Now, because of the note we just took down, I know that there's a relationship between tan of 180 minus 60 and 60 because of the symmetry. So I know this can reduce down to exactly the same answer as tan of 60. However, I need to ask myself, is it the positive version of tan of 60 or is it the negative version? Now we're working in quadrant 2, and tan of an angle in quadrant 2 will be negative. So this isn't equal to tan of 60, it's equal to negative tan 60. Now that's a special angle, so I should know the ratio of tan of 60 without using a calculator. If you have to use a calculator, that's absolutely fine. Hopefully by the time you've done this enough, you'll be able to remember these off by heart. But tan of 60 is root 3. So this simplifies down to negative root 3. So what was my first step? My first step was rewriting 120 degrees. In this case, as 180 minus theta. In our next couple of videos, we're going to expand that to different ways we could rewrite things. My second step, it was this step here. I reduced that to tan of 60. So I reduced that to the first original cousin. So I'm actually going to say that. I'm going to reduce to the first original cousin. And then my last step was fairly easy. I was meant to, without a calculator, just work out answer. So that's kind of what our steps for the whole of reduction is going to be. The only thing we're going to be doing as we expand this is there are different ways. We don't have to only work with 180 minus theta, but it's exactly the same three concepts. So our next example is cos 150. So exactly the same question. Can I rewrite 150 degrees? And again, not as anything random, not as 140 plus 10, but as 180 degrees minus theta, because then I can do this thing called reduction. Now the answer is yes, because 150 degrees is 180 minus 30. So if I draw myself a little picture, which you really don't have to, 150 degrees would be there. 30 degrees would be there. So this is actually, this angle of 150 could have been originally created by an angle of 30 that got folded over. So this cos of 180 minus 30 is going to be related to cos of 30, because that's how it was created. I just have to ask myself, is it going to be the positive cousin of cos 30, or is this a negative cousin? So I know, because we're working quadrant 2, that this is going to be the negative cousin of cos of 30. So I've reduced this down to a ratio of cos of 30. Now again, I should know the value of cos of 30 without a calculator, so this is negative, and cos of 30 is root 3 over 2. Our last example, sine 135, we're going to do exactly the same thing. Can I rewrite 135 as 180 degrees minus, hopefully, a special angle? And I can, and you can stop drawing your pictures eventually, because you start to get used to the fact that 135 is 180 minus 45. Now this is going to be exactly the same thing as sine of 45, because of the symmetry of how 135 was created. The question is it the positive cousin or is it the negative cousin? Now sine in the second quadrant is positive. So because we're talking about sine here, and because we're talking about the second quadrant, this is actually the positive version of sine of 45. Now this is a special angle, so you may cheat on your calculator. Otherwise, hopefully you know that sine of 45 is root 2 over 2. Now the next two videos are going to be exactly the same concepts, just different ways of rewriting the angle. So hopefully by the end of the next two videos, this starts to become something that you are really good at. If there's any problems with reduction as we keep going, please make sure that you touch sides with your maths teacher, because this is really, really important. Okay, hopefully you're having fun.